The Fit Spline tool is useful for several different things, one of which is reducing the number of faces that would be produced in a surface model from various parts. So in this sketch there are 4 different segments, and if I quickly just extrude this out, you can see that as a result I get 4 different faces. So if I go into the sketch, you can see I have essentially one segment that I've made curvature continuous to 2 different reference geometries, and then this was mirrored over so you get all 4 of these sections. And this is generally the best way to ensure that these are going to be symmetrical, but this also leads to those 4 faces that you saw in the extrude boss base. I also have a path for a swept surface, and this is also made up of 2 sections. So if I create this feature without making any changes, I get 8 separate faces that I have to deal with. And this may not be a problem with the parts that you're working with. It may not be an issue at all. So you can leave these as they are. Or we have the option of using the Fit Spline tool. To create our geometry. In this case, we're going to choose an unclosed spline. And the Fit Spline tries to fit to this line as closely as possible. So it'll also leave a reference geometry behind the spline. If you want to actually remove that out, you can delete this out. We also have the option of unconstraining the spline, so we can move it around, as well as fixing it. Typically, constrain will work for what we're trying to create. So now we have a single spline. If I go back into the swept surface and choose out these 2 entities, you'll see now, since I'm using the spline, I just have a single face. Similarly, if I edit this out and add that Fit Spline in, this will remove out those extra faces. I can also change the tolerance. In this case, because this is already made up of splines, this won't make much of a difference. But now if I extrude this out, I'll get one surface. And the same holds true for if I created a revolved surface. If we simply add in the Fit Spline, it'll remove out the extra face. I'm going to go ahead and draw out a segment or section of arcs. Using the 3-point arc as well as the tangent arc. And I can also take something like this and turn it into a Fit Spline. Once again, we do have that closed option, So if we left that checked, it'll close this entire spline out. Or if we simply want to convert this to a spline, you can see that we're moving from tangent continuous to curvature continuous. And based on the tolerance, this will change how the curvature adapts. Generally, we want to use as high of a tolerance as we can without getting too many issues with our curvature. And if you find it easier in a certain part to trace the model with arcs, if you can do it very closely, you can always come in and use the Fit Spline to take your surface from a tangent continuous surface to a curvature continuous surface. Lastly, I covered this part in the splines video, but I'll go ahead and just bring these two boundary surfaces back up. And one way to connect up these boundaries, as I showed in the other video, is to simply convert out edges and then use that Fit Spline option to connect these two things together. We can also edit how this is constrained. In this case, only one of these options works.